Hi everyone. So as some of you may know, tDCS and other forms of brain stimulation have been in the news recently as safe methods with all kinds of cognitive benefits, such as improving concentration, learning, and even sleep. Well, as very easy methods, many people have already started to stimulate themselves at home. So, with the growing buzz and the growing do-it-yourself community, my friends and I have decided to put together a few videos to discuss our research, the benefits, and how you can safely take advantage of brain stimulation at home. My name is Alexander David. I've been working here at the Neural Engineering Lab at the City College of New York for about 3 years, and in the next few videos, I'll be introducing several of my colleagues in the lab as well. For this first video, I'm going to start off with a bit of background into subthreshold stimulation. Neurons have a resting potential of about negative 70 millivolts. They have a threshold at around negative 55 millivolts when they enter what's called an action potential, which is a process that your neurons use to communicate with each other by sending signals. Well, with that threshold, there are two types of stimulation. One, which forces the neurons to reach that threshold and fire an action potential, and others, such as tDCS, which do not. They actually just simply raise the neuron above the minimum resting value, but not so high as to force an action potential. For many of these forms of brain stimulation, we simply apply a small current to the head, usually around 1 to 2 milliamps. What makes subthreshold brain stimulation so interesting is where we apply these 1 to 2 milliamps can cause huge differences. By moving the electrodes, we can get very different effects. For those of you who are interested in this, Dr. Bixson gives a great talk at Harvard that you can watch online. So what I want to talk to you about today is how to use brain stimulation to improve memory. The temporal lobe is one of 4 major lobes of the cerebral cortex, located on both sides of the brain. Along with several other structures and functions, the temporal lobe has substructures involved with various types of memory. It contains the parahippocampal, the perineal, and the entorhinal cortices, and the hippocampal region. Simulating deep brain structures in any meaningful way is often difficult for 2 reasons: intensity and locality. As current flows through the head, it has to penetrate several resistive layers, such as skin and skull. By the time it reaches the cortex, the current doesn't even force action potentials, which is the point of subthreshold stimulation. But what we want now is for the current to pass through the cortex and the more resistive white matter to simulate these deep structures underneath in a meaningful way. The second issue is, to have the current meaningfully stimulate the deep brain structures often means that many other regions of the brain are being stimulated which you really might not want to have stimulated. While the paper I was a part of actually shows that stimulating the medial temporal lobe does not improve memory, one of the reasons we did this study is because of all the previous studies that have shown temporal lobe stimulation does improve memory, and now the question is, which part of it is responsible? Well, what I'm going to be showing you today is a study on anterior temporal lobe stimulation, which has shown an improvement in memory. For those of you who are interested, the study is titled Visual Memory Improved by Non-Invasive Brain Stimulation. So now I'm going to show you how you can use this study for yourself to improve memory. So, the study says that by placing an anode between FT8 and T8 and a cathode between T7 and FT7, you can improve visual memory. FT7, T7, FT8, and T8 are all 1010 EEG locations. You can find the 1010 EEG system online. So the setup you need to do brain stimulation at home is pretty simple. You just get a high-quality brain stimulation device like the one I have here. I got mine here because it's FDA cleared, but you can really go for any high-quality device. It'll be around $200 to $400. You can go cheaper with these current injectors or build them yourselves, but you're putting this on your head after all, so go with something maybe the FDA knows about. The next thing are there 2 main types of electrodes we'll be dealing with. One are these sticky electrodes, as you can see, nice and sticky. And these are for putting on the exposed skin on your head. What we're going to be using today are sponge electrodes, which are going to look kind of like this. Alright, so what we have here is the basic sponge, and we're going to have to soak it in saline so it looks like this. So I'm going to do that now. Just give it a second, take a little bottle of saline, and just kind of pour it on fairly liberally, and it's going to blow up. And it's going to be right in there, no problem. Same thing with the other one. Okay, so now you can see it. It's all filled up. So then what we're going to do is attach our device to the electrodes. There's a red wire, and as you can see, a red insert. This is for your anode, and the black wire and black insert is for your cathode. And it's actually pretty important to get this right. For some studies, they've shown that flipping polarity will have no effect, and for others, it'll produce the reverse effect. So, pretty important to get this right. So now we have to keep them in place, and I just have a headband like this. You can really use anything, a sweatband, doesn't matter. So our placement was a bit above and a bit past the ear, so luckily bilateral simulation was pretty easy to set up. I'm just going to put my headband around here, a little above the ear, and then, what the study said. I'm going to put this between FT8 and TH, right around there, and then I'm going to put the cathode on the left side in FT7 and T7. So now you're all set up to do brain stimulation. I'm just going to turn on my device and set the dosage. And so clicking here is me setting dosage. You're going to see dosage usually in milliamp minutes. Now that's just the current times the time. And as we said before, it's around 1 to 2 milliamps of current. So you're thinking that you're doing maybe about 15 to half an hour of stimulation very often, because you'll see something like 60 milliamp minutes. So I like to set up for myself 1 milliamp, 1.5 milliamps for maybe 15 or 30 minutes. So I do a little bit less, 20 to 30 milliamp minutes. It's, just really what I find comfortable when I'm doing this. The one thing is when you have setups like this, especially around the face and the eye, is there's an optic nerve and you might see some flashing. I'm actually pretty good when it comes to that. I don't really get too much, but I introduce some of my friends to this and they do get the flashing. So just not a big deal. It stops when you take the simulation off. So otherwise, enjoy brain stimulation at home.